Okay, so question 8. Depict the electron configuration of magnesium using an orbital box diagram and noble gas notation. Give us a complete set of 4 quantum numbers for each of the electron beyond those of the preceding noble gas. So first, let's find the electron configuration of magnesium. Okay, so to do this, we would need to divide our periodic table into different sections that show us the different orbitals. So for example, on the periodic table, the first 2 columns and helium, which is shown in light blue, is the S block. This green kind of rectangle is the P block, and the middle transition metals is the D block. And finally, the last 2 rows, the lanthanides and actinides, is the F block. So to find the electron configuration of a certain element, we need to start at hydrogen and move from left to right down the periodic table until we get to our desired atom. So we would want to write the row number first and then the block number as we move down. And we also want to show how many electrons are in each of the orbitals for that ground state element. Okay, so starting at hydrogen, we can write the electron configuration. So it starts off with 1s and then 2. So this is equivalent to the electron configuration of helium. And then when we write 2s2, this is up to the beryllium. And then onto the P block, we have 2p6, and then 3s, and then magnesium is right here. So it's just going to be 3s2. So if we wanted to write this electron configuration in the shorthand way, using the noble gas, it would just be the noble gas that comes right before magnesium, which is neon. So I'm going to write neon in square brackets, and then 3s2. Okay, so this is the electron configuration. The question also asks for the orbital box diagram. So, not sure if they want us to write it in the full notation or the shorthand way, but I'll just do it the full way just in case. So we start off with the 1s orbital that houses 2 electrons. And then the 2s has 2 as well. And then 2p contains 6 electrons. And then finally, the 3s contains 2 as well. And then now we have to give the complete set of quantum numbers. So let me just write it down here. and they only want to give it for the electrons beyond those of the preceding noble gas. So we're only going to be looking at the 2 electrons in the 3s orbital. So let me just write for the first electron. N is just equal to the row number that it was in. So in this case, it was the 3s. So N is just equal to 3. And for the L quantum number, this is determined by the block number. So if we had a block number of S, P, D, or F, S is 0, P is 1, D is 2, and F is 3. So this is that chart. So when we have an electron in the 3s orbital, its L value is equal to 0. So this means its ML value is also equal to 0. And the spin of that electron is plus half. So this is the electron that's pointing up. And now I can do the same thing for the second electron in the 3s orbital. So it has the same N equals 3, L is still equal to 0, ML is still equal to 0, but this time its spin is pointing down, so it will be negative half. So this is that electron, and the one pointing up is the red. Okay, so let's see what the junior tutor said. The electron configuration of magnesium in orbital box diagram and noble gas notation is given by neon 3s2. And then they showed 2 electrons, and then 1s2, 2s2. Okay. So the set of quantum numbers for the first electron pointing up in the 3s orbital is n equals 3, L equals 0, ML is equal to 0, MS is equal to plus half. The set of the quantum numbers for the first electron pointing downwards in the 3s orbital is n equals 3, L equals 0, ML is equal to 0, and MS is negative half. Okay, so for the orbital box diagram, I'll just say that this solution is correct. There's just like a typo, or maybe like something up with the image or the box diagram. I'll just try to type out what it should look like. Maybe it was just a typo.